This video is about simplifying using the law of exponents. So remember that when we evaluate, if a number is more than 4 digits, we're going to leave it in exponential form. So, product of powers. So when we are multiplying powers that have the same base, so example 2 and 2, you are going to add the exponents, but the base does not change. So for example, if we have a to the m times a to the n, it's going to be equal to a to the m plus n. Or with more numeric values, 2, which would have an exponent of 1, times 2 to the 5th is equal to 2 to the 1 plus 5, which is 2 to the 6th. So remember, it has to have the same bases in order to combine together. So solve the following expression. So in this one we have 5 to the 7g times 5 to the 2g. So our base of 5 stays the same. We're going to add those exponents, 7g plus 2g, which gets us 5 to the 9g. In number 2, v times v to the 12th. Well, v would just have an exponent of 1 if nothing was written there. So our base is v, and we're going to add those exponents. 1 plus 12 gets us v to the 13th. In number 3, we have a base of f because we have f to the 9th, f to the negative 5th, and f to the 2nd. So we're going to add those exponents together, 9 plus negative 5 plus 2. So 9 plus negative 5 is 4, plus 2 is 6, which gets us f to the 6th power. Number 4, we have parentheses negative 2 to the 2a times parentheses negative 2 to the 11a times parentheses negative 2 to the 6a. So negative 2 is our base, and we're going to keep that in parentheses. And we're going to add those exponents. So 2a plus 11a plus 6a. So we have 2 plus 11 plus 6, which is 19a. So we have negative 2 to the 19a power. Now, in number 5, our bases are still the same of g. So we're going to have g to the 12 plus 20. 5 and 3 do not have exponents, so those numbers are able to multiply together because of the multiplication sign. So 5 times 3 gets us 15. So when we simplify this, we're going to get 15g to the 32nd power. Number 6. Now we have two different bases. We have an x with the powers of negative 2 and 8, and we have a y that has a power of 6. But all the numbers in front that don't have exponents, 2, 4, and 2, can all multiply together, and it doesn't matter which base they were with. So 2 times 4 times 2, 2 times 2 is 8, times 2 is 16. So we have 16x to the negative 2 plus 8 and y to the 6th. When I add those x exponents, I get 16x to the 6th, y to the 6th. Number 7, we have two different bases here. We have the negative 3, so we have parentheses negative 3, 4v plus 3v, and we have 5 that have exponents, so 5 to the 13w plus 8w. This time, 5 and negative 3 don't multiply together because they both have exponents with them. So we're just going to simplify the exponents by adding them, so we get negative 3 to the 7th v times 5 to the 21st w. Number 8, we again have two bases. We have m, which is this last one will have an exponent of 1, so we have m to the negative 3 plus 8 plus 1, and we have k to the 12 plus 14. We also have some coefficients here. We have 3, 10, and 5, so we can multiply those all together. 3 times 10 is 30, times 5 is 150. So this simplifies to 150m. When I add this together, negative 3 plus 8 is 5 plus 1 is 6m, and k to the 26th power. Now, the second exponent rule that deals with multiplying is when you have one base raised to two powers. So we're going to have one power inside a parenthesis and one power outside the parentheses. What's going to happen in this case is you are going to multiply the exponents, and the base still does not change. So here we have a to the m parentheses to the power of n, so it would be a to the m times n. With the numerical values, we have a base of 3 to the 4th, and then parentheses to the 5th. So we're going to multiply 4 times 5, and we get 3 to the 20th. So in number 9, our base is 3, and we're going to multiply the exponents 3 times 5. So we get 3 to the 15th. 10, we have c to the 9th parentheses 3g. So when I multiply c to the 9 times 3g, 9 times 3g is 27g. So we have c to the 27g. And our last one, we have parentheses negative x to the 4th, parentheses 4. So we're going to have negative x still in parentheses, and we're going to multiply 4 times 4. So we get negative x to the 16th power. Now this exponent, the next exponent rule, is just saying what happens when there's multiple things in our parentheses. So if you have many things being multiplied in the parentheses, we're going to multiply the exponent to each of the terms inside. So for example, a and b would both get that exponent multiplied with them. M would both get M and N would also get the exponents with them. So in number 7, we're going to take all of these exponents and multiply by 3. So j to the 3 times 3, k to the 11 times 3, and m to the 5 times 3. So it's just like the law before, but now there's more bases that we're going to multiply to. So we get j to the 9th, k to the 33rd, and m to the 15th. In 15, we're going to multiply all of our exponents by 10. Even if 5 doesn't have an exponent, remember that's a 1 then. So we would have 5 to the 1 times 10, a to the 9z times 10, b to the 2y times 10, and c to the 5x times 10. So 1 times 10 is 5 to the 10th, a to the 90th z, b to the 20th y, and c to the 50x. Now, if I want to make sure that 5 doesn't need to be evaluated, 5 caret 10, this number is bigger than 4 digits, so we're just going to leave it in exponential form of 5 to the 10th. So let's do some mixed practice. So in number 14, the two numbers that are 5 and 20 don't have exponents, so they can be multiplied together to get us 100. And then we only have one base, so we're going to add those exponents. So w to the 3z plus 14c, which gets us 100 w to the 17th z. 15. When we multiply, we have coefficients of 5, 3, and negative 5 on the outside. So 5 times 3 is 15, times negative 5 is negative 75. Now, we have two bases. We have x's and we have y's. So the x exponents will get added together, and the y will stay by itself of y to the 8th. So this simplifies to negative 75, x to the 11th, y to the 8th. Number 16, we have a parenthesis with an exponent. So remember that we're going to multiply everything in the parentheses with that 4. So 2 to the 1 times 4, x to the 3g times 4, and y to the 4 times h, times x to the negative 5g, y to the h. So let's simplify this a little bit further before we start combining our bases. So 2 to the 1 times 4 is 2 to the 4th, x to the 12g and y to the 4h, times x to the negative 5g and y to the h. So 2 to the 4th, if we put that in a calculator, 2 caret 4 is 16, so we're going to write that as 16 now. We have two bases here. We have the x's, so we have x to the 12g plus negative 5g, and we have y's, so we have 4y to the 4h plus h. So when this simplifies, that gets us 16, x to the 7g, y to the 5h. So let's look at three more examples. In number 18, notice that we have some zero exponents. So let's deal with those first. So we have here a zero exponent, which gets us just 1. And here we have a zero exponent, which is 1, but that has to multiply it to 3 to get us 3. So we now have negative 8 n to the 5th times 4n to the negative 12th. So we can multiply all of these numbers together since they don't have a exponent. So if I do negative 8 times 3 times 1 times 4, we get negative 96, and we're going to add those exponents, 5 plus negative 12, which gets us negative 96 n to the negative 7th. Remember that we're not allowed to have negative exponents, so the negative 7 with the n needs to move to the denominator. Negative 96 doesn't move because we can have negative numbers, not just not negative exponents. We're going to have negative 96 over n to the 7th. In number 18, we have 4n to the 14th, y to the 15th over 8, n to the negative 5th, and y to the negative 8th. So first we need to move these negative exponents so that we can combine the n and the y powers. So they need to move to the numerator. So we have 4 n to the 14th, y to the 15th, n to the 5th, y to the 8th, all over 8. So the n exponents can combine together by being added. So we have 4 n to the 14 plus 5, and the y exponents can be added together for 15 plus 8 over 8. So when we add those exponents together, we get n to the 19th, y to the 23rd. Now the numbers 4 and 8 can be reduced because we can divide both of those numbers by 2. So when we do, or we can divide them both by 4. So 4 divided by 4 is 1, so we don't need to write the 1 on the top. But 8 divided by 4 gets us 2 in the denominator. Our last problem, number 19. So we need to multiply the exponents on the outside of the parentheses with the exponents inside the parentheses. Remember to keep your numbers in parentheses when we are moving our exponents around. So we have negative 3, which has no exponent right now, so 1 times negative 2, a to the 3 times negative 2, times, and in the next parenthesis, 2 to the 1 times 4, x to the 7 times 4, and y to the 1 times 4. So when this simplifies, we have parentheses negative 3 to the negative 2 times a to the negative 6th times 2 to the 4th times x to the 28th times y to the 4th. So anything that has a positive exponent can stay in the numerator, which is 2 to the 4th, x to the 28th, and y to the 4th. But negative 3 in parentheses and a both have negative exponents, so they're going to move to the denominator. So we get negative 3 squared and a to the 6th. And remember, when we move these, they become positive exponents. So the last thing we can do then is we can evaluate 2 to the power of 4, which is 16. So we get 16x to the 28th, y to the 4th, and parenthesis negative 3 squared, which is 9, a to the 6th.